This is another video concerning the stoichiometry and mole concept and related concepts. In this video, I have tried explaining some problems which students find rather peculiar to solve, if not difficult. So without wasting much time, let me come to the problems straight. With question 1, and these have been taken from ICSE books. Question 1, find the molecular formula of a hydrocarbon having vapor density 15, which contains 20% hydrogen. Given is atomic weight hydrogen 1 and carbon is 12. So the solution, a hydrocarbon contains only carbon and hydrogen. Therefore, if hydrogen is 20% as it is given in the question, then the percentage of carbon is 100 minus 20, which is 80%. Now, hydrogen is 20%, carbon is 80%. So percentage divided by atomic weight equals 20, and percentage of carbon divided by its atomic weight 12 is 6.67. Using the least of these two, which is 6.67, I divide 20 by 6.67, which is 2.99, approximately 3, and 6.67 divided by 6.67 equals 1. So the empirical formula of hydrocarbon is C1, carbon 1, and hydrogen 3. So C1H3, or simply written as CH3. Now, molecular weight equals twice vapor density. And the vapor density given here is 15. The vapor density given here is 15. So 2 into 15 equals 30. Molecular weight equals empirical formula weight into a number, and n equals 1, 2, 3, 4, 5, whatever it is. But it should be a whole number. Therefore, the molecular formula is equal to empirical formula into n. Now, n is 30, that is the molecular formula weight, or the molecular weight divided by the vapor density, which is 15, or empirical formula weight, which is 2. Therefore, the molecular formula is n into CH3, which is 2 into CH3, because the value of n is 2, so C2H6. And this compound is written as ethane. This can be an extension of the question, name the hydrocarbon, and you get 1 mark for that. So that is ethane. C2H6 is ethane. This may be an extension. Next, aluminium carbide reacts with water according to the equation Al4C3 plus 12H2O gives 3CH4 methane and 4AlOH thrice, which is aluminium hydroxide. Calculate the mass of aluminium hydroxide formed from 12 grams aluminium carbide. Second, what volume of methane is obtained from 12 grams of aluminium carbide? And given, it will always be given for grade 10. This is not competition, it is a general examination, so atomic weights we do not have to remember or learn by rote. They are given to make the calculations easier. So aluminium is 27, carbon 12, oxygen 16, hydrogen is 1. According to the stoichiometric equation, this is the stoichiometric equation, it is balanced. 4 into 27, because aluminium is 4 atoms of aluminium here, so 4 into 27 plus 3 into 12, which is 144. plus 12 into 18, one molecule of H2O equals 18. A molecule of H2O equals 18, and therefore we have 12 molecules of water here, so we have 12 into 18, which is 218 grams. And this gives, after reaction, CH4, 12 plus 4 is 16, so 3 into 16 is 48 grams CH4 methane. And similarly, 4 into 27 plus 3 into 17, which is 312. 3 into 17, because 16 plus 1, 17 here. 16 plus 1, 17, and into 3. So 3 into 17. We have 312 grams of aluminium hydroxide formed. This is if 144 grams of aluminium carbide reacts completely with 218 grams, and these are the results: 48 grams methane and 312 grams aluminium hydroxide. So 144 grams aluminium carbide gives 312 grams aluminium hydroxide. The question is, calculate the mass of aluminium hydroxide formed from 12 grams aluminium carbide. So we take this and this. Two weights can be taken, and this is a weight-weight relationship. One weight is given, we have to calculate the other weight, and we have to use the standard weights as the stoichiometry of the equation says. So 144 grams aluminium carbide will give 312 grams of aluminium hydroxide. Therefore, 12 grams aluminium carbide will give 312 divided by 144 into 4, which is 8.6 grams aluminium hydroxide. This is based on weight-weight relationship in a stoichiometric equation. Number 2, 144 gram aluminium carbide gives 3 into 22.4 liters of methane. In my earlier video, I have explained that this is the molar volume of a gas. 1 mole of gas at STP occupies 22.4 liters. The reaction taking at, suppose the reaction is taking place at STP, then 3 moles of CH4 are formed, in which case the volume will be 3 into 22.4, because the volume for 1 mole of any gas, you see 1 mole of gas equals 22.4 liters. Therefore, the problem is based on moles is to mass is to volume relationship, and to solve this question we will use the equation 1 mole is equal to 1 molecular weight is equal to 22.4 liters of a gas at STP, if gases are there in the question. So we have a gas, chlorine is our gas which is in question, and we have volume of chlorine and moles of chlorine to be calculated. Now, according to the given stoichiometric equation, we have 87 grams MnO2 plus 136 grams HCl giving 126 grams MnCl2 plus 36 grams H2O plus 71 grams Cl2. Also, in terms of moles, 1 mole, see this is 1 mole, 4 moles of HCl 1 mole of MnCl2 is to 2 moles of water and 1 mole of Cl2. Therefore, mass of MnO2 used equals moles into molecular mass, which is 0.02 into 87, which is 1.74 grams. Straight, 1 mark. Moles of salt MnCl2 is given that it is now if we go to the equation, the relation between MnO2 and MnCl2 formed is 1:1. So if MnO2 used is 0.02 moles, it is 0.02 moles of MnCl2 formed, because the relation is 1:1 between MnO2 and MnCl2 in this equation. Moles of chlorine also is 0.02, as 1 mole of MnO2 is converted into 1 mole of Cl2 by 4 moles of HCl. Volume of chlorine is mole into 22.4. So instead of molecular weight, we will use 22.4. So because 1 mole of chlorine will be equal to 22.4. So 0.02 moles of chlorine will be equal to 22.4, which is 0.448 liters. So chlorine formed is 0.448 liters. Moles of HCl used is 0.02 into 4, which is 0.08. The reason is that in the stoichiometric equation, MnO2, 1 mole of MnO2 reacts with 4 moles of HCl. So moles of HCl used is 0.08 moles. Mass of HCl is number of moles into molecular mass. The molecular mass is the molecular mass of Cl2 will be 1.42. This is not HCl, it is Cl2. So number of moles into this, and mass of HCl, MHCl, will be 0.08 into 36.5. So you can multiply this and find out the answer. All you need is a calculator or pen or pencil and a paper. We have another question. Question 4. Urea is sold in 50 kg sack. In sacks which can hold 50 kg urea. What is the mass of nitrogen in it? The formula of urea is CONH2 NH2, or we can write, you say, NH2 CONH2. So there are two NH2 in the formula. So that's why NH2 hold twice in CO. The molecular mass of urea can be calculated thus: carbon is 12, oxygen is 16, and NH2 14 plus 2 is 16, and there are 2. So 2 into 16, which is together 60 AMU. Molecular mass expressed in AMU. Suppose the molecular mass is expressed in kg, then 60 kg urea contains 28 kg nitrogen. In this, nitrogen is 14, and 14 into 2 is 28. So if we take this instead of AMU, if we convert this to kg, then out of the 60 kg urea, 28 kg will be nitrogen present in it. Or 50 kg urea is 28 by 60, 28 upon 60 into 50, which is 23.33 kg of nitrogen. I hope you are able to understand. No matter how much we explain, you have to take the cues from here and practice n number of numericals to be able to get full 15 or 20 marks that a numerical will carry in an ICSE paper. Question 5. 0.2 gram atom of silicon combines with 21.3 gram chlorine. Find the empirical formula of the compound. Atomic weight silicon is 30 and chlorine is 35.5. We must know that 1 gram atom is equal to atomic weight of the element. Therefore, 0.2 gram, 0.2 gram atom of silicon is 0.2 into 30, which is 6 grams. So we are combining 6 grams silicon with 23.3 grams chlorine, and together the weight of the compound, with law of conservation of mass kept in mind, will be 6 plus 23.3 is 29.3 grams. Percentage of silicon is 6 over 29.3. Weight of element divided by total weight of compound is 20.48, and percentage of chlorine is 79.52. 100 minus 20.548 is 79.52. Now, dividing this by the atomic weights, we have 0.68 and 2.24 here. So this divided by the lowest quotient is 0.68 divided by 0.681, and 2.24 divided by 0.68 is 3. So the empirical formula of the chloride formed is SiCl3. Some people who may have learned that the valency of silicon is 4, so they will cross the valency of silicon with chlorine, which is 1, and they will arrive simply at the formula SiCl4, which is wrong. It has to be calculated, and then the answer has to be given. So in this case, it turns out to be silicon trichloride instead of silicon tetrachloride. Question number 6. Barium chloride crystal contains 14.8% water of crystallization. Find the number of molecules of water of crystallization per molecule. Atomic weight of barium is 137. Hydrogen, oxygen, we already know because it is given elsewhere in the video. And chlorine is 35.5. Now let the unknown formula of barium chloride hydrate be written as BaCl2.xH2O, where the value of X is to be determined. So the percentage of BaCl2 as water of crystallization is 14.8%. The percentage of BaCl2 taken as 1 unit is 100 minus 14.8, which is 85.2. The molecular weight of BaCl2 using the atomic weight of Ba as 137 and Cl is 35.5, we have 137 plus 71, which is 208. Or now finding out the percentages, using the percentages to find out the number of units that will be present. We have 14.8 divided by 18, which is 0.82, and 85.2 divided by 208, which is equal to 0.41. Now, using the least of these, we can find that this is 2 times this. So we have 2 here and we have 1 here. That means 1 unit of BaCl2 is there and 2 units of water molecules are present. So the formula is BaCl2.2H2O. The number of moles of water is 2. I hope you understand. Please go to the notebook, use your pen, solve as many numericals as possible, or you can refer them to me in comments and I'll do the needful. Type of numerical is this. A compound with empirical formula AB2 has vapor density equal to its empirical formula weight. Find its molecular formula. We know that molecular formula weight by empirical formula weight is equal to N, where N equals 1, 2, 3, and so on and so forth, whole numbers. Also, molecular weight is equal to twice vapor density. But according to equation, empirical formula weight is equal to Vd by question. So substituting for Vd empirical formula weight, we have molecular formula weight equals 2 into empirical formula weight, all theoretical, or molecular formula equals 2 into AB2, which is empirical formula given in the question. So 2 into A1B2 is A2B4. So these are the few numericals that I thought I must solve and present it before you for your understanding. I hope you have got the point and you will practice more and come back through your comments to tell me whether this was good enough or not. Thank you. Looking forward to seeing your comments. Please do comment. It gives us an impetus to do better for children all over this country. Thank you. Have a nice day.